Hello everyone. Today I would like to introduce about the NI LabVIEW. So I have planned to prepare a consecutive training on different topics about NI LabVIEW, and today is the first sessions on NI LabVIEW. Myself is Shajit Banerjee. I have almost 13 years industry experience in NI LabVIEW and other data acquisitions platform. So let's start with the today's sessions. So today's session is basically for the introductions to LabVIEW. So what is LabVIEW? Full form of LabVIEW is Laboratory Virtual Instrument Engineering Workbench, and it is an integrated development environment designed to accelerate the productivity of engineers and scientists. And what are the main key features of NI LabVIEW? So first one is the hardware integrations, customizable interface, extensive analysis and signal processing algorithm, graphical programming and data flow models. So I would like to elaborate one by one. First point is the hardware integrations. So LabVIEW integrate with NI, different data acquisitions platform, and other third-party hardware also, like maybe manufactured by Keysight, Agilent, Tektronix, any kind of device or test and measurement devices mainly, like any oscilloscope, function generator. So that can be integrated with a single platform that is called NI LabVIEW. So engineers have or scientists got the benefit, like they can control and they can measure the different types of test and measure equipment in a single software environment that is called NI LabVIEW. Second features is customizable user interface. So LabVIEW provides easy to use applications development environment designed specially for the needs of engineers and scientists. And it can be like customizable because you can configure the entire GUI in your LabVIEW. Okay. So third one is the graphical programming. So if you were familiar with any other text-based programming language like NI, like C programming, C# or MATLAB programming, that follow the text-based language, right? So you have to remember the coding, syntax, and algorithm, all those things. But in case of LabVIEW, it uses the totally visual programming language, like how we are thinking about any particular algorithm. The same thing we can implement as a visual programming or graphical programming level. Okay, so making it intuitive and easy to learn. So without having any pre-experience about NI programming, you can easily start the LabVIEW because it's totally graphical programming. Okay. So third point is the data flow programming model. So instead of text-based programming, usually follow the different rules for executions of the coding, either left to right syntax or right to left syntax. Okay, but in case of the LabVIEW, it's follow the data flow programming model. So data flow programming models means any particular function or block will be executed when all the inputs are available, right? So suppose we are going to solve these equations. That is, our output will be a plus b multiplied with the c plus d. So operations in any syntax-based programming language like C or MATLAB, how we can do that? So first we can additions a plus b, and we can store in any variable called x, and then again we need to addition c plus d, and it will be stored in another variable called y, and then finally we will get the output which is equals to x multiply y. So how many steps is required? It is 3 steps is required to complete the entire executions, right? But in case of the LabVIEW, as it is follow the data flow programming model, how it will be executed? So in this cases, as it is totally parallel executions, so there are 2 addition block, right? So both the addition block require the 2 different input. So whenever the a value and b value is available, first additions will be executed, and whenever the c value and d value is available, then another additions block will be executed, and both will be executed simultaneously, right? So after completing the additions of the 2 different additions block, and then when the outputs of the both additions is going to the input of the multiplications block, then after completions of the multiplications you will get the output result. So total number of steps it's required only 2. One steps for the both the additions and the second steps for the multiplications. So in case of the LabVIEW programming, at it's having the parallel processing, so different applications or different algorithm can be performed simultaneously if it is not interrelated of any of the sometime maybe like one input is related to the other output. At that time it will be sequential level. But if it is not interrelated of the or all the input of the different nodes or blocks are independently, so then it can be executed parallelly. So that is the advantage of the data flow programming model. Then the built-in analysis tool. So LabVIEW, it's already almost more than 40 years of development. Nowadays, LabVIEW having a huge extensive library functions for the different signal processing, mathematical analysis, filter. If you go with the transform function, spectral analysis, digital filter design, adaptive filter, different types of signal processing algorithm is already available. So user no need to start from the scratches. They can use this block diagram to make their own algorithm, or they can utilize those block diagram and they can modify those things to prepare their own applications. So that is the help for the built-in analysis tools. Then we are like to introduce about the LabVIEW programming environment. So if you go to open the LabVIEW, and there is an option called File, and if you go to File, and then you can click New VI. Usually the LabVIEW programming extensions, program file extension will be .vi. VI stands for virtual instruments. Like if you write the C programming, its extension will be .c. For MATLAB programming, extension will be .mat. Same thing for the LabVIEW, the extension will be .vi. So then after click the file and new VI, so you will get two different window has been created. So one is grayscale window, that is called the front panel window. Another one called the block diagram window. Okay, so like what are the significance of these two different window? So if we right click here, so the grace color window, it's called the front panel. It's basically user interface sections. So user interface means it comes with the different control, different types of indicators and panels will be there. Suppose knob, suppose if I go to the numeric, and there will be some slider. Okay, and same thing if I go to the some graphical waveform, like waveform graph. So these all called the user interface sections. So one thing, so whenever we will put any kind of user interface in the front panel, at the same time you can see the same instance has been created at the block diagram panel, right? So block diagram panel is basically for the programming, or you can implement the complete algorithm inside the block diagram panel. So if we explain, so front panel of the VI, that contains the user interface of the VI, and the front panel can be simple with a few inputs or control, or along with the output or indicator. So mainly two different part. One is control or input value, and indicator or output value. And the user interface of the code in the block diagram, it may be control, maybe different control like Boolean control, numeric control, string control. Okay, as well as indicator will be like different, like graphical, graphs, chart, numeric indicator, etc. Okay, and so suppose if I go to in this block diagram panel, you can see it's a graphical waveform graph, and a knob and slider I already put here, right? So suppose I'm just putting some kind of Boolean switches. So you can see it's a horizontal switches and some kind of like maybe some LED. Okay, and size and everything that can be changes as per your requirement. You can change the graphical size, or if you see the different changes the name, changes the size of the display, everything, size, color, style, everything you can change in the front panel side, right? Suppose I need to put its output. Okay, and suppose I need to change the size of this kind of wording. So as per my requirement, we can easily change it, right? So suppose we need to like put some kind of, I just at the time when the instance has been created, we just need to connect the blocks. Okay, connect through the different where we can connect in this way, right? So in the block diagram panel, suppose we are going to the express VI, and there is a called input. Suppose we put some simulate signal. Okay, so inside the simulate signal, so in the function generator, different types of signal can be generated, like sinusoidal, square, triangular, sawtooth. So suppose if we set the frequency range of a particular signal is the 50, and the 50 hertz, and amplitude is the 10 volt. Okay, and suppose if we click as OK, so then you can see these all are the different types of input. Suppose by changing the knob value, we will control the amplitude of the particular signal. Okay, so for that we need to just connect through where. So from the knob output, we just need to connect with the amplitude sections. Suppose by changing the slider, we change the frequency of the signal, right? So for that, we just need to connect with the where through the frequency point to this slider. Okay, and the what are the sinusoidal waveform that will be displayed into the waveform graph. So we need to connect through the where. Now if we go to the our front panel window, and then if we can run, and also we can change the value and sizes. Suppose we put the amplitude 10, and frequency, in case our executions frequency is called 50, right? So suppose maximum will be 50 hertz, right? So in this way, suppose if we run continuously, I will explain this one, like there is what is the difference between run and run continuously. Letter section, suppose I put some amplitude and I change some frequency, you can see the same sinusoidal waveform is coming. Suppose I'm changing the this one switches, so LED on and off, is going on. So it's running continuously way, right? So this is basically the user interface sections. And if we go to the block diagram panel, and there is an option called the highlight executions, you can see how the data passing from one point to another point. You can see the amplitude value and frequency value is going. Then this simulate signal block has been executed, and the data is going to the waveform graph. At the same time, what are the input at A terminal? There is the Boolean switches, and that pass on output is going to the LED sections. Okay, so if we change the value in the real time way, at the same time, you can see if we check, yes, so you can see at the real time also the data has been changes, and the data, how the data flow from the one point to another point, you can easily verify from the this highlight options. So what is called the block diagram? So block diagram basically white color panel, and which comes with the different types of functions like mathematical functions, signal processing, different kinds of loop, structure, array. So all these kind of functionalities, like program functionalities, that will be occur inside the block diagram, where you will implement your programming algorithm inside the block diagram. And the front panel basically comes with the controls and indicator part. Okay, so in case of our programming, if we go to our particular segment, if we right click here, you will find the block tag. This is called the function palette. Function palette, it's include the different types of, this is the structure, means programming structure, like for loop, while loop, case structure, event structure. And this is the array function, different array functionalities, different types of like reverse array, find some particular element from the array, or there is search 1D array or rotate array. We'll explain the array functionalities one by one in the later sections. Then the string. At the same time, if we go to the like mathematical functionalities, you can find the numeric functions, then the different types of elementary special functions like trigonometric functions like cosine, sine wave, triangular, different tan. Okay, so different functionalities you can get. The same thing for the exponential, hyperbolic. Okay, and so same for the signal processing. You will get different types of waveform generations, like different types of basic functionality like sine wave, square wave, triangular, ramp function, sawtooth waveform. Different functions you can generate here. Signal generation section is there. So signal with some kind of particular noise, that also you can generate. Then if you go to the signal processing part, then it's called the waveform measurement. Okay, so inside a waveform, if you want to measure some amplitude or frequency or any particular functions like RMS value, basic DC value of a particular signal, that you can perform from the waveform measurement sections, right? So along with that, there is called different kinds of signal operations like convolutions, deconvolutions, correlations. So those kind of signal processing toolkits or signal processing functionalities are available inside the signal processing sections, right? And if you go to the different types of control and simulations part, then inside the control and simulations means maybe PID, fuzzy logic, everything that can be implemented in your control and simulation segment. And there are some control design. Okay, suppose he wants to implement some control transfer functions. If you want to put some kind of PID logic or fuzzy logic inside your control system design programming, therefore that control design segment is important for you. Okay, and along with that, called the vision and motions, different types of like image processing or the vision related activity like image, different types of image processing algorithm that you can find inside the vision and motions. We'll explain how each of the segment one by one. So for now, I'm just moving forward to the block diagram sections, right? So if you're going back to our presentations, so there is two palettes, so we would like to elaborate. One is called the control palette, and other is called the function palette. So what is the control palette and what is the function palette? You already saw that control palette that comes inside the front panel or user interface sections, that comes with the different kinds of graphical waveform or graphical chart, numeric indicator, numeric control, or Boolean control, Boolean indicator. All the user interface segment comes inside the control palette, and inside the block diagram you will get the function palette. Function palette contains the VI and functionalities that is used to build the block diagram or to complete your complete implementations of your algorithm. You need to have some function, some mathematical signal processing functions that comes inside the function palette. Okay, and the VI and the functions are located on the sub palette based on the types of VI and functions. Suppose if you if you need any kind of programming, okay, so programming that comes under the programming and structure side, and suppose if you need the mathematics functionalities, okay, so that comes under the mathematics. So in this way, the sub palette has been defined. So name of the sub palette like called programming, measurement IO, instrument IO, vision motion, mathematics, signal processing, data communications, control simulation. Those names are basically, it's called the sub palette. Inside the sub palette, you will get the every individual functionalities, right? So this is the significance of the function palette, and inside the your front panel, you will get the control palette. Okay. So now if I moving forward, so suppose we need to create, this is the first example, we need to create a VI to add the two different number and how we can implement that. Okay. So if we start from the beginning, suppose we need to create new vi. Okay, so if we click on the control T, so both the panel will be coming side by side. So we need to add the two variable, right? So for that we need to put the two numeric control, one numeric control and another numeric control, and we need to define the name. Suppose this I put the name A, and this for this control I put the name as B, and we need to define as an output. Output will be numeric indicator. Suppose I'm putting the name as a C is our output. Okay, so at the same time instance has been created, and then we need to go to mathematic functions. Okay, so if we go to mathematics and numeric sections, you will find the addition block. Okay, so just put the addition block. You can see there is two input point, so we just need to connect through where A and B. Okay, and the output will be connected to the C. C will be our indicator part. If we run continuously, you can see if we change the value of A, if we change the value of B, you can see it's a addition operation has been performed and it's running continuously. Okay, so if we stop these executions, okay, so now the important part is the data types in the LabVIEW. So inside the LabVIEW, you can see different types of data, like including numeric. Inside the numeric, you will find the different integer as well as floating point, fixed point, Boolean, string, array, cluster. These are the different types of data which is usually used in the LabVIEW programming environment, and each represent by the different where color and used by the specific data storage and operations. Okay, so suppose for the numeric, it's if it is the integer value, its color will be blue. If it is floating point, it will be floating point or decimal value, it will be color significance by the orange. Okay, so Boolean usually used by the green color, and string operation and string functionalities, that will be where color will be pink color. Okay, so this is the different types of data types. Okay, so if we moving forward into the next slide, now the classifications of the numeric data type. Okay, so inside the numeric data type, so integer means represent the whole number without any decimal point, right? It may be positive, it may be negative value, but it will be whole decimal, means a whole number without any decimal point. Okay, so LabVIEW support the various integer type like signed integer, okay, signed integer 16-bit, signed 32, long, quart. So different types of integer value, signed as well as unsigned integer, is available inside the LabVIEW programming environment. Okay, and same thing for the floating point. Floating point represents the number with the decimal point, suppose 3.14 or minus 2.5. Okay, and LabVIEW uses the single precision, double precision, and extended precision for the floating point number. Okay, so we need to define the what is the range of the each data type. Okay, one by one. So first thing is the unsigned byte integer. Okay, so unsigned byte integer will be, range will be as it is unsigned, so everything will be like a positive value, right? No negative value. So positive value starting from 0 to 2 to the power 8 minus 1. So that will be 2 to the power 8 means 256 minus 1, 255. So range will be 0 to 255. Okay, and the representations icon will be U8, and the U16 means unsigned word integer. Okay, so that value will be 0 to 2 to the power 16 minus 1. Okay, same thing for the U32 or unsigned long integer. That value or range will be 0 to 2 to the power 32 minus 1, and the same thing for the U64, define the unsigned quad integer. So, and for signed, it's starting like I8, and then I16 means signed word integer, I32 means signed long integer, and I64 means signed quad integer. Okay, so the difference will be signed means it's starting with the from negative to positive. Okay, so like total number of if it is I8, so total number of element will be 256. Okay, so its range will be minus 128 to plus 127. Okay, so in this way we can represent the different data types inside the LabVIEW. So if we go to the programming environment inside the LabVIEW, see, in our cases it's represented as a DBL. What does it means by the DBL? So DBL basically stands for the floating point. Okay, so for floating point and double precisions. Okay, and the same type for the floating point number, and LabVIEW include the single precision, double precision, and extended precisions, and which can be in the both real and complex number also, right? So this chart refer to the range of the all the different floating points data types. Okay, so how we can change the data types in the LabVIEW? Suppose if we need to change into the integer, just right click on the particular block, the functionalities, then go to the representations, and inside the representations there is an options called I8. I8 means it's a like signed integer. Okay, so signed integer, what is the maximum value of the signed integer? So this function is also we need to change, otherwise both the data types will be different. Okay, so here also I change the signed integer. So you can see the red color because the we can see this data type is different. Again, we need to change this one also, sign integer. Okay, and if we go to the our programming chart of the maximum and minimum value, if it is the i8, so range will be -128 to plus 127. If the data is beyond that particular range, what will happen? We'll change, we'll check those things also, right? So suppose we need to run continuously. So we know the range is -127. So suppose I put a equals to -150 and b equals to c. If we put the -150, it's not taken because the maximum value will be -128. And what is the maximum value? That is called 127. Suppose if we put the 200, what will it take? That is take the maximum value only, right? So only this is the range. So suppose if we just stop the programming and if we just change the value representations, suppose I put inside the, in case of u8 to i8 to change the unsigned 8-bit integer, right? So if it is unsigned integer, I also change this one unsigned integer, and I change this one also representation unsigned 8. Okay, so now if we execute this one, so if I take any kind of minus data, so minus data will take no, answer will be no, because why? It's only take the positive input value from 0 to 255. Okay, so suppose one value is 128, other value I put the 300. What will happen? So if we check that, that will take only the maximum result. That is, the maximum result is 255. Okay, so based on that, the data will be calculated. Okay, so how we can explain this calculations? So suppose we are putting, we know the range of the unsigned 8-bit integer, that is 0 to 255, right? So if we put the more than that value, so it will not take. Okay, so if it is, if we try to put like 300, it will not take. Okay, so but what is the summations result? That is how we can explain those things. So suppose we are adding 255 plus 130. Okay, so what will be the result? That is 385, and 385, and as it is range is maximum is 255. So if we subtract those things, I'm just use the calculations. So what will be our result? So 255 plus 130, right? So what should be the result? 385. But what we are getting? 129. So what is the difference? 256, because the entire range will be 256 only. Okay, so suppose if we change any particular value, which suppose 130 plus 140. Okay, so what will be the value? So 130 plus 140, that is 270, and our output result will be the total 270 minus 256. What will be the data? That is called the 14. So in this way, we will get the maximum data in LabVIEW based on our representations of the data type. Okay, so now I'm moving forward to this slide. Then if we explain about the Boolean data type, so Boolean data type basically represent the binary value, either true or false. There is only two conditions, right? And it's stored as an 8-bit value, where 0 value represents the false and any non-zero value represent the true cases. In LabVIEW, Boolean data is represented by the color green. All the where going to and coming from a Boolean objects are green color, and the icons are outlined in green on the block diagram. Okay, so if we want to implement how we can use the Boolean, we already explained. Suppose we are going to put the front panel. If we stop the programming, so how we will get the Boolean? So right click and going to the control palette. These are the Boolean segment. Inside the Boolean segment, you will get different types of switch: push switch, rocker switch, vertical rocker, and there are different LED like round LED, square LED. Okay, and different types of sliding switches also available. Suppose we are putting the two different switches, two different toggle switches. Okay, and suppose we are putting some kind of square LED as our output segment. Okay, and we just enlarge those icon to better visualizations effect. So this also we are increasing. Suppose we are giving, this is name called A, this is name called B, and we are Boolean means it's a digital, means either on and off, and this is our output data, right? So suppose we are putting the out. Suppose we are implementing some kind of a Boolean or digital logic, right? Suppose we are putting some kind of AND operations. So put the AND logic. So this is the A and this is the B. So A and B operations will be displayed inside the square type LED. And we put another options called the OR gate. We put the OR gate and we put another like LED, maybe like round shape LED we put here, and we enlarge this one. Suppose this is the output for the AND gate, right? right? And this is the OR gate. So this is the Boolean output for the OR gate, out OR. Okay, so now we need to connect this to terminal. This connect to the A terminal, and this Y connect to the B data control, right? And X or Y that will be displayed to the output OR. Okay, so this is the Boolean functionalities. Now if we run this program, you can see if we A and B, what will be the output? If A equals to 1, B equals to 0, the AND output will be 0. Okay, 0 or false, but OR output will be 1. Okay, if the alternatively A equals to 0, B equals to 1, so again AND output will be 0, but OR output will be 1. If A and B both equals to 1, so in this cases both the data like AND gate output and OR gate output both will be 1. If the both the things will be 0, the AND output and OR output both will be 0 or off stage. So in this way we can explain the Boolean functionalities, and we can implement any kind of Boolean logic by using different kinds of gate like AND gate, OR gate, exclusive OR, NOT, or any compound arithmetic if we want to implement that also we can do. Okay, so now we are going to our presentation slide. So suppose we have to implement different types of multiplexer, right? So suppose in a digital electronics, it's a very common, it's a multiplexer. If we want to implement 4x1 multiplexer, so 4x1 means there will be 4 input, and based on the selector line or control line, our output will be defined, right? So suppose S0 and S1 both are the selector line. So if the both S0 and S1 equals to 0, then Y means output will be first input, that is called the I0. If the S0 equals to 0, S1 equals to 1, our output will be second input, that is called I1. And if the S0 equals to 1 and S1 equals to 0, our Y or output will be third input, that is called I2. And if the both S0 and S1 both equals to 1, then our output will be fourth input called the I3. So we can implement this truth table. So our equation will be, we got the final equation like that. Okay, so what will be the circuit diagram? So this will be the circuit diagram. Okay, so there are different AND gate of the 3 input and 4 input OR gate functionalities are there. So how we can implement inside the LabVIEW functionalities? So for that we already implemented. It's very easy to implement because there are different functionalities are already available inside our LabVIEW programming environment. So for that I'm just opening. Yes. Suppose we are showing the block diagram. Yes. So you can see there are the S0 and S1 are the select line, and I0, I1, I2, I3 are our input. So suppose if I hide the I0, so I0 equals to 1, or remaining are all are 0. If we run this one programming, so now see S0 equals to 1, S0 equals to 0, S1 equals to 0. So which input will be passing to the output? Only I0, right? So if we run continuously, so based on our select line S0 equals to 0, S1 equals to 0, only I0 will be passing to the output segment for 4x1. So if I on and off I0, based on that our output value will be changes, right? But it's not depends on any kind of I1 or I2 or I3. Okay, so in the same cases, if the S0 equals to 1, S1 equals to 0, right? So what will happen? Then you can see, suppose S1 equals to 1, so you can see only based on the second input, that is the I1 will be passing to the output segment, right? So if we on and off, depends on I1 status, it's passing to the output segment, right? And then the next condition will be our S2 equals to S0 equals to 1, S1 equals to 0. So then the third input will be passing to the output segment, right? And if the both S1 and S0 equals to 1, then you can see only the fourth input, that is called I3, will be passing to the output channel. Okay, so in this way we can implement the 4x1 multiplexer. So this is a simple example I am showing. You can implement any Boolean algorithm using the functionalities using LabVIEW. Then we are moving to the string function. So string functions means strings data type. Basically, then we are moving to the string data type. So string data type store the text data, everything from the name, status message, or any details descriptions, and it's converted data into the written file. And string move along with the pink where. So the string control and string indicator color is basically pink, and the where color also will be pink color where it's used for the string data type. Okay, so if we wants to implement inside the LabVIEW, just we are going to the same VI. Suppose if we go into the front panel window, just right click here, and there is options called string control. Okay, so string control, I'm putting one string control, and I'm just also putting one string indicator segment, right? So you can see both the color is pink color, and if we connect in the input equals to output, both the terminal if I connect it. So if I run here, so if I type like hello world, okay, so when we are enter or execute this thing, the same value will be displayed into the indicator segment. So this is called the string data, and inside the string segment you will find the different combo box also options. Combo box means it's a string of the array of a string value. So we can create the different combo box. So suppose we need to select the 5 string input based on our setup, we can do that. So that is combo box, but we'll explain combo box functionalities in the later part. Okay.